Hello, everyone. My name is Nate Thompson. I'm a specialist with Kendall Electric, and I'm here today to show you a demo and to discuss configuring and setting up a SIG200, which is an IO-Link master IP67 block from SICK, as well as tying it into a SIG100, which is a IO-Link device that is a digital input and output block that SICK also makes. I'll show you the demo here so we can talk through it real quick. So what I've got set up here is a SIG200, which is an IO-Link master. That's tied into a SIG100, which is all digital outputs and inputs configurable. And then I've got it wired into a couple proxies, a couple push buttons for reset signals, and a green and red light. And what we're going to simulate here today is if you've got some machinery that is older or doesn't, it's more mechanical, but yet you still want some data back to it, back to like a ignition or a Viva or some kind of plant-based monitoring system. Instead of having to go down the route of a PLC and an HMI and all this additional logic and stuff that can get pretty costly and get out of hand pretty quickly. SICK has allowed you and given the ability to put logic inside of their IO-Link master and even this digital IO block to do simple and or exclusive flip-flop type logic that you can do some simple processes to allow the machine to continue to operate but have an auxiliary function to be able to monitor and pull some smart data out of that old mechanical machine and be able to monitor things, maybe do some more preventative maintenance, things like that. So what we're going to do today is I want to take you through the setup process and some initial configurations, and then I'm going to show you the demo. And then we're going to play with use Insomnia, which is another software you'll see outside of SOPUS, which is SICK's engineering program. And I'm using Insomnia, it's free, and I'm using that to simulate the plant-based monitoring software like Ignition or Aviva, something like that. So first things first, to connect to, you want to connect to the SIG100 first and configure your ports and your logic. So you can configure the ports through the SIG200 because obviously the 100 is an IO-Link device and you can configure it over IO-Link. What you cannot do is handle the logic that's built into the SIG100. I am not going to connect to it because I ran out of USB ports. If you need to connect to one, this is the cable and the part number that you want to get. Your local Kendall shop can handle that for you guys and gals. But this is the USB configuration cable that you would want to connect to your SIG100. And that would plug into the port up here on the top right. Again, you don't have to necessarily spend time configuring the ports and everything else. You can do that through the 200 when you log into it later. But I typically want to do things, as efficient as I can. So I'm already logged in. I would just go through and configure it. But configuring the ports looks identical between the 100 and 200. So I will show you on the 200, but just understand that it's the same on the 100 as well. The big thing that we want to do when we log into the 100 is to take care of some logic. So the logic editor looks identical in the 100 to 200. There's just some additional tools in the 200 that you don't get on the 100. Obviously because it's not an IO-Link master and there's no field bus communication, so you're a little limited. Since all my logic, my control logic is going to reside in the 200, we still need to map a few things and link a few things together. So what you need to think about is the communication between the 200 and the 100 is just like making two PLCs talk to each other a little bit. So you've got inputs and outputs on the 200, and you've got inputs and outputs on the 100. So what we want to do is we want to take the inputs that we are going to control, or that we need to control on the 100. We need to map those to IO link outputs from the SIG100 so it can talk to the 200. Okay, if that makes sense. So we take and click and drag, and this is just a picture, so I'll show you again once we get to 200. Mapping it to QL6, QL7, and QL8. Okay, these are just digital inputs on pin 2 for port 4, 5, and 6 on the 100. I also do the same thing with the outputs that I have configured. So each port, okay, has two channels. You've got pin 2 and pin 4. You can set one of them as an input and one of them as an output. You can set both of them as outputs. You can set both of them as inputs. To let me bring up so you can actually see. So these cables, because they're regular prox cables, what I did was I mapped pin 2 as my input and pin 4 as my output. So my brown wire and my white wire are going to my input buttons. See, that's pin 2 on ports 5 and 6. My lights right here are wired up the black wire and the common wire, the blue wire. So that's pin 4. So when we turn those outputs on, you'll see those turn on. The proxies are wired through these cables up here to ports 1 and 2. Now I could have used a splitter and wired them both into pin 1 or pin 2, doesn't matter. I didn't have my splitters on me, so I just used 2 different ports. But it's very important that you map these signals that you're going to be communicating with over the two devices. Once you do that, there's a button up here, and you'll see it in the 200 when we get to the logic that says transfer and run. You click that, you'll get a loading screen right here, spinning for like a couple seconds, and then you'll be good to go. It'll go back to gray again. So that's the only thing that we did in the 100 that was required so that the outputs and the inputs would actually work. You can map all of them. That way, if you add something later, it's there, but I didn't want to take the time to do that, but feel free to do that if you want. Okay, so let's log into SOPUS. So we start SOPUS up. As soon as you start it up, it will search, and it should find the SIG200. I am logged into it through the Ethernet. The default IP address is right out of the box is 192.168.0.1. You're either going to want to set a static IP address in that same subnet so you can link up to it. If that doesn't work for some reason, there is a chance that the SIG200 came to you configured as a boot P device. If that's the case, you probably want to set your computer to automatically get an IP address, and then it should work. That was a hiccup for me logging in on this device the first time, but this is also a demo that's been passed around to other specialists, so it could have been set that way for other reasons. But just a little FYI. So if you double click on your icon, SOPUS error will open up, and this is what it will show up at the start. So it shows you little statuses of what's going on your IO master. It shows you the current configuration of the ports. So pin 4 is all set to IO link. Pin 2s are set to digital inputs, and I have one connected device. Now, right off the bat, this would show up as empty because you haven't loaded the IODD file yet. So if you go down to configuration, the first thing you're going to do is set your IP address, set static or boot P, whatever you need for your application, and then hit apply. You can cycle power if you want. You don't. I don't think you have to. I don't remember off the top of my head. The next thing you can do is come here and set your Ethernet IP settings. If you're talking to an external device that requires or needs Ethernet IP. If you don't need it, you don't have to set this. You can just leave it as none. But you can go all the way from 2 in, 0 out, or 0 in, 2 out, all the way up to 128 in and out. So a lot of data you can pass back and forth. The other thing you can do is change the configuration of what it looks like, so how it's broken down. So I've got it set to have a 2 byte and then a 1 byte that is split into 8 bowls, just for display purposes. I'm not really using this in this demo at all, but I just want to just be able to show you some of the differences. Once you have your configuration set the way you want, you hit apply and you're good to go. The next tab is your IO-Link ports. So this is where you're going to configure who the port owner is, what your labels are, what your pin configuration is, and what device you have plugged into each port. The very first thing you need to do, whether it's another SIG device or a third-party IO-Link device, you have to upload your IODD file. You can download all of these device files that are at least SIG from their website, or if it's a third party, get it from them. And then once it's loaded, it will show up on this pull-down menu. If it doesn't show up here, it didn't successfully load it. So you have to retry again. Being that I have the SIG100, excuse me, tied to port 1, which is right here, this connection cable. So the thing to remember is your power connection on the SIG100 is your IO-Link connection as well. So you just run that to whatever port you want. You come over here and you select your IODD file for that device. It will pull the expected device ID and the vendor ID number automatically once you select it. And then you need to look at who the port owner is going to be. So there's 3 options. There's a field bus option if you have an IO-Link master with a field bus on it. You have REST, which is for REST API. We'll get into that a little bit later. And then logic editor. The way to think about this, the best I can tell you, is who is going to own and control the port. Okay, like let's think about if you had an output of some sort, like a valve or something. Who's controlling that output? Who's controlling that port? In my case, for demo purposes, I'm not getting commands and stuff from a field bus. This is meant to be a standalone control demo, right? So it's not that. My REST API connection is only going to be writing integers for the logic and is going to be pulling data from the logic. It is not controlling anything. So I'm not going to make this the port owner either. So I'm going to leave it as logic editor. Once you're happy with all your settings, you can hit apply and it will write that configuration to the control. The last thing you can look at here is your IO-Link devices. This is how it's broken out into each port. Now, as you can see, it takes just a second or two for this thing to populate. You got to remember that as fast as these things are, this is a lot of data that is pulling in all at once. So you can get a snapshot view of all of your inputs and all of your outputs for that port. Okay, if you had another device like a W10 or some other smart IO-Link sensor plugged in this port, you would see different information here. Just as before, like I said, you can come in here and configure the ports for the SIG100. Again, like I said, I already did that when I connected to it earlier when I was setting the logic up. I was already connected to it. I might as well do it there. If you forget or need to change it, you can do it through the SIG200. That's the glory and the beauty of using IO-Link devices. You can configure it all through the master, and you don't have to go into each individual sensor and figure it out. So that's the same kind of information for all three ports or all four ports. So now we get into the power of this device, okay? Everything I've covered so far, any IO-Link master can do pretty much until you get to this. This is the logic editor for the SIG200 and the SIG100, as you saw pictures of earlier. To map anything, you just hold it, click on the arrow, drag, and it'll highlight what it's able to connect to. If it's red, you can't connect to it, even if the arrows are the same color. All the arrows are color coded. So your grays are booleans, your reds are integers, and your yellows are floating numbers or real numbers. As you can see up here, you have a lot of math and or logic, digital logic that you can use. Heartbeats, flip-flops, switches, comparisons, timers, a lot of powerful, good tools. Converters. You can go from bytes to or integers to bits, integers to floaters, um, booleans to integers, and so on and so forth. Analog. You got delays. You got a lot of good capability here for a very simple control. So, I, this particular customer that this demo sort of surrounded around, again, they didn't need a full PLC and HMI. They just needed something they can mount to the side of the machine and can get some data out of it. With this device, there's no need for a enclosure. There's no need for any of that. Everything that they want to use is going to be washdown capable, dust capable, things like that. So they can just mount it right to the side of the machine and they're good to go. So again, same thing as the 100. You've got all of your incoming signals and all of your outgoing signals. Now, um, as well, you can see the configuration of the Ethernet IP matters because now I've got um, it shows the breakdown here of those signals if I wanted to use them. But again, I'm not tied to anything that's talking Ethernet IP, so I don't worry about it. Um, Basically, what this logic is doing, just in a real quick, is I'm monitoring how many cycles this machine, quote unquote, has had. And when those cycles have been reached, whatever that number may be, a maintenance or a tool change or something has to be performed. So what we've got here is if you look at the demo again on the bottom right of your screen, these proxies are going to simulate a cycle start um, press. These blue ones are acknowledgement that my preventive maintenance or the tool change or whatever it is has been completed. And then the green light is saying I've reached my cycle count. Red is I've gone over my cycle count. You need to stop right now and do your preventive maintenance. The output that's on right now is meant to be a third light, which is you haven't reached your cycle count yet. It's meant to be an amber light. I don't have enough lights on this demo, so you're just gonna have to look at the light for now. Um, the value that's coming in for my level B integer here, my comparison, that's actually coming in from ignition or insomnia in this case, my simulator that we talked about earlier over the REST API. My outputs that I'm outputting to REST API are my current um, cycle count within my preventative or tool change or whatever else you want to call it, and then the total machine cycle count. Now, again, these values, this PLC is, or this control is not a full-blown PLC with retained data and all kinds of other stuff like that. If you cycle power, if you re-download your logic, these counters are going to reset back to zero no matter what. Now, there's ways around it. If you're monitoring this data and you said, hey, before we power off, it had 67 cycles on it, you can come back up here and log into it and actually start the counter at 67 again. But that's not accessible from outside the logic, so you'd have to log in and do that. But again, this is meant to be a single add-on data collecting control. We're also taking the comparisons. So if it's less than, if the cycle count is less than my comparison, this output is on. If it's equal, my green light's going to be on, and if it's greater than, my red light's going to be on. So really simple logic, really simple application. Um, but if you want to look at um, the demo again, I'll show this working. So right now I'll hit the reset button to make sure that my counters are all squared away. 1, 2, 3, 4, 5. My light turns on. If I hit it a sixth time, I went too far, right? If I reset the counts, I've done my tool change. Now I'm able to cycle the machine again, right? Okay, that's great. So we're going to jump to Insomnia here, and this is where is a free software that you can download, and this is where we're going to look at the um, in the programming. One of the great things SIG does is the operation manual really does a great job of breaking down the commands, the methods, the JSON programming that you need to be able to send and get data back and forth from the SIG200. So that's always available to look up. But I love Insomnia to simulate like an ignition software because you can use your URI, you can check it, you can put your JSON in, and you can immediately see the feedback from the request that you send. So one of the things I've programmed here already, I've programmed 5 things to pull out of this demo. First one's going to be the process data for the inputs. Now this is just a snapshot of the statuses of my inputs on the SIG 100. Um, Using the same URI, all I got to do is change this process data from in to out, as you can see here, and now I have a snapshot of all of my outputs. And you can see here that output 11 is on, which lines up with our port here on port 4. That's all great, but so that REST API in and out is for the physical statuses of the ports on the SIG 100, right? Um, the thing to remember here too, before I get too much farther, this port number on the header that I have programmed here on both of these, you have to remember that with the REST API and the programming in JSON, the port numbers are labeled 0 through 3 and not 1 through 4. So port 1 on the SIG200 would be programmed as port 0. Port 2 on the SIG200 would be port 1 in JSON. So just an important thing to remember when you're writing these requests. Um, if we really want to get this REST data, so let's go back to the logic here real quick. So we need to send our cycle count to the SIG200, right? Because it's obviously not going to be 5 when we run the machine. It's going to be 100 cycles or 200 cycles, whatever it may be. We don't want to be coming into the logic every single time and writing this value as a constant, which is what these are up here, these cons. We don't want to constantly be writing this, okay? We want that data to come from ignition or come from an outside source. So we've got it tied into a REST input, but we also want to get the total machine cycle count and the current cycle count in that PM cycle out as well to ignitions for monitoring. So we have them mapped here. So if we go back to Insomnia, or ignition if you want to call it that to simulate, the first thing we want to do is send that cycle count. So the URI obviously changes quite a bit, but again, this is pulled right out of the operation manual. So all the commands you see are going to be the values you need to put in after your IP address. So you're going to do IP address / and then you're going to paste whatever command you have from the manual. So the JSON code again is right out of the operations manual. It's just data, the offset value, and then the actual value that you want to write. The offset value is very important. So again, this is which bundle of rest packet location are you writing to. So if I scroll back down here in the background, you see I've got one here, and if I was to connect this rest in to another integer, it would automatically add another one and another one and another one as I was connecting. These are labeled the exact same way as the port numbers are. So this first one that I'm connected to is 0. This one would be offset number 1. The next one, if I had a third one, would be rest input 2, and so on and so forth. Same thing with the outputs. The first one in line is going to be 0, then 1, then 2, and so on for the offset. So being that I'm wanting to send my cycle value to my very first rest input, it's going to be offset 0. And then whatever value you want. I'm just going to leave it at 5 for now. So you send it. I got a 200 back. That means it's written. And we can check that if we go back to the demo here. If I reset this just to make sure, and go 1, 2, 3, 4, 5. So we're good. Okay. So that works. The other thing we want to do is we can get we want to get this cycle count here. So how many cycles do you have left out of that's in this current PM cycle? So we have that mapped to the first rest output. So let's program that one. So we switch here. Again, we're getting a value. Okay, if you look at this one, the setting. Okay, we're setting a value. We're writing the cycle count. But this time we want to read what that cycle count is. So we're going to get the rest data out. Again, we're offset 0 because we're on our first output here. If I request that, we're at 0 because I just reset it. Now if I come and cycle this, we're going to go 1, 2, 3. If I send this again, we now have a value of 3. Okay? And that will keep counting up until I reset the cycle. So if I hit reset right now, that just reset my counter back to 0. If I resend this get command, my counter's 0 again. Okay? So that's keeping track of my PM cycles. But what about my total cycles? How do we get down here? Now remember, the only thing I said differently between this rest output and this rest output is the offset number. So we can use the exact same code that we have here. We can duplicate this to your total count. The only thing that changes is this offset value. The URI stays the same. The actual JSON code stays the same, other than I'm changing my offset number. So now if I hit send, I've cycled this thing 66 times without a power off or without a re-download again. And we can see if that works because I'm going to hit this several more times, make the red light come on, okay? And then hit send again, and it counted up to 91 now. So that's the total, that's simulating a total machine cycle count. So this is how you can get data in and out to an IT level data collection software like Ignition easily with the SIG200 just by using REST APIs. So this little IO Link Master is so powerful. It really gives you the ability to write auxiliary functions, auxiliary logic control to do simple tasks and get data in and out up to Ignition as much as you want. So really powerful tool. And hopefully you've got some applications that you would love to use this on that would make your life easier and make maintenance and IT's life a lot easier. So if you need anything like this at all, feel free to reach out to your local Kindle branch and we would love to help you. Have a great rest of your day.